So, welcome everyone. Thank you for coming. Today I want to talk about how to profile PHP applications. So I'm not going to talk too much about the theory. I want to show you how to actually profile a page with PHP. I'm going to talk about different tools. But first, why would you want to actually profile a page? So profiling an app is a great way to better understand what's going on in your code, better understand the behavior of the code at runtime, so while it actually runs. And of course, the main goal is trying to optimize the performance of your code. So before diving too much into more details, I have a couple of questions for you. The first one is, how many of you write unit tests? Well, almost everyone. For real?
It's becoming more of a It's becoming more of a thing. It's becoming more of a thing.
Okay.
I think.
I think it's more and more common, and if you are not running unit tests, you feel bad about that, right? Which is the first step. You feel bad and then you try to do something about it. So now, how many of you are actually continuously testing the performance of your apps? See? Not that many. But I think that, performance is really important. I'm not going to talk about what is on the screen here, but obviously the faster your app is, the better it is for your users. Right? And many big companies did some benchmarks and they demonstrated that engagement and conversion rates are much better if the website is faster. So it does make sense to actually try to make your website faster. So for me, performance is a feature of any app, like any other feature. It's probably almost as important as unit tests or any test. I'm talking about unit tests, any kind of testing. If you break a feature because you don't have a unit test, that's catastrophic. But if a page is too slow, it's not good either. Because it means less business. But apparently, developers do not care that much about performance. And that's probably because the tools are very difficult to set up, very difficult to use. So they are not very user-friendly, and I think that's a shame that it's not part of the developer workflow. On a day-to-day basis, you should be able to test the performance of the new feature you're adding, or if you don't have any regression before going to production. And when we are talking about performance, we are talking about something that depends on a large number of factors. Don't ask me why I chose this picture. It has nothing to do with performance. But it's kind of cute. So the number of factors is really important. So for instance, the time it takes for the page to be generated by PHP, for instance, or the time it takes for the browser to render the page. So it adds up a lot. But today I'm not going to talk about all those kind of performance problem. I'm going to only talk about the server side of things. So the performance of the PHP code that you are actually executing to render a response. So to be able to figure out what's going on in your code, we need to instrument the code. And a profiler instruments your code to get data, more information about what's going on when the code runs. So those data can be the memory consumption, for instance, the number of times functions are called, and of course the duration of the execution of functions. And of course, if we need to instrument the code, it means that there is some kind of overhead. Right? We need to hook up. Whenever there is a new function call, we need to instrument that. So, and the overhead should be as minimal as possible. If it is too big, you won't be able to profile a page in the production environment for sure, but also it means that it's going to skew the results. And so for instance, doing profiling with xdebug, it's not a very good idea, because the overhead is too important. And that's why, by the way, that's why people think that print is actually, I don't remember, print is actually slower than echo. That's wrong. The only difference is that print is a function, echo is not. It's a language construct. The other difference being that print returns true, and echo being a language construct, there is no return value. But the speed is exactly the same. But because there is a big overhead when you want to instrument a function, print appears to be slower than echo. Right? So if the overhead is too much, the results are not good. So when I say performance, you probably think of speed. So the time is probably the most interesting dimension when we are trying to optimize the performance of an app. But the time comes into several different flavors. The first one I want to talk about is wall clock time. So the clock on the wall, so this is really the duration it takes for PHP to execute some code. So from entering the function to leave the function. That is the time it takes. You can also, sometimes it's called just wall time or just time. So basically you have a function, whenever you want to call foo, the wall clock time is really the time it takes for PHP to execute everything within the function. This is what we also call the inclusive time. Inclusive means that this is the time it takes for the code belonging to the function itself, plus the code executed by any other calls within the function. So the function call plus all the children. The inclusive time is very important to be able to have a look at the critical path of your app. So this is where most of the time is spent. So this is a good indication of where you need to look at to be able to improve the performance of your app. But you can also have a look at the exclusive time. So the exclusive time is the time spent by PHP for things in the method itself, so without all the children, right? And this one is interesting so that you can find the functions that you need to optimize first. If you have any questions, anytime, please ask me. So, and when you talk about the time, it's the time it takes for the CPU to actually run your code. But the CPU is also dependent on external factors. So, the time it takes for the CPU to execute your code, plus the time the CPU waits for some kind of input-output, network or disk. So, if you are calling a web service, or if you are reading a big file on disk, or if you are using MySQL, for instance, this is some kind of input-output. So the CPU is just waiting for the data to come back from the disk or the network. And so the I/O is very important to spot the functions where some intensive I/O activities take place. So this is where you have some Redis calls, memcached activities, or whatever. Also, keep in mind that the I/O is also about very small cost. Reading from memory is not zero, so having zero as an I/O is just not possible. memory access is not as fast as executing some things on CPU. So talking about memory, it's also interesting to have a look at the memory used by PHP, because of course the more memory you are using, the more it takes, the more time it takes for PHP to store things into memory and to retrieve things from memory. So it impacts the performance as well. Okay, I'm not going to read the whole things, but you know that you need to optimize when you are ready to optimize, not before that. So the thing is, you need to ensure that your application is going to run fast enough on your production servers. The goal is not to optimize everything, right? Take a few seconds to understand the slide. It's very true. But of course, so it means that not everything should be optimized. So instead of shooting in the dark, trying to figure out where the resources are actually spent in your code, in order to be able to optimize it, you need to use some tools. And a profiler is something that you can use to better understand what's going on in your code. So since the beginning, I'm talking about profiling and the profiler, but when we are talking about performance, there are other tools, other techniques that you can use to actually try to better to improve the performance of your website. So benchmarking, load testing, monitoring. Monitoring, it's very easy. It's like Neuralink. So you are in a production environment and you want to monitor the performance of your app before it runs. Monitoring is great if you want to learn more about the slow pages, for instance, but it's not going to help so it's not going to tell you why it's slow and how you can fix that. A profiler is really something that you can use to understand why it is slow and how you can fix the problem. Wow, I'm going to skip this one. So most profilers in the PHP world are actually call graph profilers. A call graph profiler shows the call times for functions, the frequencies of the functions calls, but also the call chains. So which functions actually called other functions. So that's why it's called a call graph. So the first tool I want to talk about is XHProf. So I'm not going to talk about xdebug because I think it's not the right tool for the job. XHProf is a tool that was created by Facebook, and they were using XHProf in their production environment for a long time. They are not using XHProf anymore because obviously they are not using PHP anymore. So the tool is not maintained anymore by Facebook.
What are they using?
Sorry?
What are they using instead?
Instead of ACK? Yeah. This is a new language that they created. So
is it based on?
Yeah, so the syntax is almost the same as PHP, but they added more features on top of PHP. It's more strict than PHP, so it's a bit different. But it's not PHP anymore.
PHP is valid active, right?
PHP, no. Actually, no. Yeah, exactly. And also, yeah, it's okay. We can talk about it. So XHProf is not maintained anymore by Facebook. So there's a fork named uProfiler. You can get the code at this URL. You need to use this one just because if you are using PHP 5.5 or 5.6, XHProf does not work. So
Does not work?
Sorry?
I'm sorry, does not work?
Does not work. So it works for PHP 5.3. I think it works for 5.4. But if you try to use it for 5.5 or 5.6, it's not going to work. I think it compiles, but it crashes actually.
Okay.
So I forked XHProf last year, and we've done some improvements performance-wise. performance-wise, we fixed some leaks, we had some improvements, and we added support for PHP 5 and 5.6. So, so the problem is that it's very easy to install XHProf, pickle, install XHProf, done. We don't have a pickle. We are not on pickle for profiler, so you need to actually compile it yourself. It's not that difficult. So you go to the extension directory. So this is kind of easy to do. And if you are on Windows, good luck. Okay. I'm not even sure it works on Windows actually. And then you need to enable it in your php.ini file. You also need to install Graphics because if you want to be able to visualize your profile as a bulk graph, your profiler or XHProf depends on Graphics to do that. And I highly recommend you to read the docs. It makes sense. But there are a lot of very interesting things described in the docs to really understand how to use your profiler or XHProf. This is basically the same documentation. So now I'm going to show you how to use XHProf, and hopefully it's going to work. Okay, so here on my laptop I have the symfony.com website. You can probably, so is it large enough for everyone? Yeah? Okay, so this is the Symfony website. The first thing that you need to do is you need to instrument the code. So you need to change the code so that XHProf or your profiler actually does something. So I'm going to get it some code. Where is it? Okay, so this is a Symfony app, obviously. So I need to enable the profiler first. Okay, I'm doing something, and at the end of the request, I need to disable the profiler. There is a bunch of options here. So basically here I've enabled everything. Actually I'm going to remove this one. And then it's up to you to do something with the data. So this is an array, and here I'm using, So uProfiler or XHProf comes with two different parts. The first one is a C extension, so that you can instrument the code. And the second one is a set of HTML files and PHP classes so that you can display the profile in the browser. So basically here what I'm doing is I'm saving the data on disk under a name of index, whatever. Should probably be symfony.com or something like this. And actually we're not going to. Okay, after doing that, I'm going to use, just a minute. Actually, so here I have this one. So again, this is symfony.com website. I'm just running the built-in PHP server. Okay. Okay, so let's refresh the page. It doesn't work because I need to enable XHProf, so PHP. Okay. And here I'm going to enable uProfiler. So this is the extension, and here I'm saying that I want to output all the profiles under the template directory. So let's restart the server, switch back, refresh. It works. And now I want to have a look at results. So here I've downloaded a second part of PHP Profiler. So this is the HTML directory under the main repository. And here I have a bunch of PHP files. So again, I'm going to use the built-in server port. And let's open a new tab. Okay. So this is so XHProf lists all the profiles that I have for under the TMP directory. I'm going to have a look at the last one. So as you can see, I have several ones. I have several ones because I have the web debug toolbar, which is another request. So I'm guessing that the page is this one. So here you have the profile from XHProf. So you have the hold time for the page, the number of function calls, and then you have the list of all the functions that were called to be able to render this page. So as you can see here, the main is a bit special. So this is the root of the tree. Right? So this is the main entry point of your app. And then you have a bunch of calls, functions, PHP ones, Symfony ones, whatever. The number of calls and the time it took for a function to execute. And if I go on the right, so here you can see the inclusive time, you have the exclusive time as well. So you don't have any information about the memory or the I/O. And then, so that's how you can try to figure out what's going on.
So what request is that?
This is the main request. So this is this page.
How do you know that from the?
Oh, because I've just refreshed the page.
But how do you know from the profiler listing?
Here?
No.
Here? So just because of the date.
So if you have multiple requests, you have no idea that you have like 10 requests in one page.
You can because here you can give it whatever name you want. Right? So it's possible. Okay. And then
you have the name and address of the web designer.
or Facebook. So and now, if I want to learn more about one specific function call, I can just click on the link, and then you can see the parent function. So the main function called my function actually, and this function in turn called those functions. Right? And now, trying to figure out what's going on. I've been using XHProf for 5 years now, and that's really nice. That's why there is the call graph. So this is a visual call graph, and now you need to wait a bit. Okay, and this is the call graph. Yeah, graph is. Yeah. So it's using the dot utility to be able to generate the graph. So as you can see, or cannot actually, I have this big image. So in yellow, this is the critical path. But oh, let's try something. I'm going to refresh the page. Okay, so this is another profile. So you can see the dimensions of the file here. So this is a very large image. So let's have a look at. Okay, let's refresh. So it should be this one. Again. And now I have a problem. I have a problem because the critical path is not the same. Same page, same code, everything is similar, but the critical path is not the same. why?
Caching.
No. It could be.
You know?
No, because I refreshed the page before, so. Yeah.
Different I/O times.
Yeah, the thing is, my machine is doing a lot of things. A lot. Which means that you can't have the same critical path, except if you have a big problem, if you have a big bottleneck, 10,000 of, 100 requests to the database, then you're going to have something very stable, right? If not, if it's more subtle, then you're going to have different critical paths. But how can you work if it's not stable? You can't. So that's a problem. So what we can do here, we can get the run ID from here, go here, and say I want to aggregate those two profiles, right? Then refresh again. What? You can't do that for the call graph, really? Let's try here. So let's copy and paste this one. Okay, so you can't do that for the call graph. But here, so as you can see here, this is a report for the aggregation of the two profiles.
Can you do more than two? Can you do more than two?
Yeah. Basically, you can add as many as you want.
Just add it together.
Yeah. I think there is an average. Yeah, it is averaged because here the number of calls is 1 for main. So obviously yes. So that's how you can have something more stable. But then again, you can't have the call graph, which is a shame.
What is that link to the call graph?
Sorry, I can't.
The link to the call graph there.
Oh yeah, sure. Let's try. No,
okay.
it doesn't. Okay, anyway.
Didn't you say that this view is kind of useless? It's hard to figure out?
It's not useless, but it's very hard to work with. Very, very hard. So again, if you have a big bottleneck, it's very easy to spot. So you can say, okay, I want to sort by the number of times a function is called. So as you can see, this one is called a bunch, really. So, or you can say, I want the exclusive time, for instance. So I know that if I want to optimize something, I can probably have a look at those 5 functions first, right? Because the exclusive time is are the most important for this page. So 12% of the time is spent in this get listener info. So we might want to be able to optimize this one.
Something related
Yeah,
to
sure.
right?
This example is not that great because this is Symfony.com in the development environment. So, but if I have a look at something that comes from the website itself, let's just
Optimized it too much.
it's very optimized. Yeah. So, I'm going to show you a not so optimized page on Symfony.com later on. There is another function feature that you can use as well here is the ability to actually compare 2 different profiles. So you can say run 1 equal run 2 this, and then this is a comparison between the 2 profiles. So you have a div between the first run and the second run. I'm not sure if you can aggregate as well. No, you can't. And that's a shame. That's a shame. But anyway, so that's that's XHProf for profiling. We're trying to figure out where. Okay. So XHProf comes with a lot of problems. If you're trying to use XHProf on Drupal, for instance, you will not be able to have the call graph because the image is going to be so big that it won't work. It's very difficult to browse image. There are many nodes. It's very difficult to to figure out what's going on in those big tables. The installation is quite difficult. There is some overhead in the production environment. You need to change your code to actually instrument the code. So that's a bunch of problems with XHProf. But it's open source. So I'm not going to talk about xdebug because the big overhead. So by the way, XHProf is using a standard output, which is the call grind format, which means that you can use standard tools like XHProf to actually load the profiles. So as you can see, this is more or less the same as XHProf, more colors probably. You have the call graph, it's using graphics as well. And here, where am I? Okay, there's anyway. Okay, so now I want to talk a bit about Blackfire, which is a new project that I've been working on for the last 8 months or so, trying to solve all those issues. So basically trying to give the developers a great tool, easy to install, so that you can very easily profile pages, and then a better visualization tool so that you can really understand what's going on in your code. If we're for PHP, we also support more languages, and we give you information about the memory, the CPU, and the I/O. So it's not open source. It's not open source because one of the goals is to simplify the developer experience. So to be able to do that, the infrastructure is quite complex. So there is, so you need to install the C extension on your servers, but then there is a SaaS service so that you can visualize the profiles. But it's free in the sense that you can download the tools for free, and we have a free plan, which means that for everything that you can do with XHProf, you can do the same with Blackfire for free. And the first paid plan is going to be very cheap. That's ridiculous. €9 a month, really? Anyway, so Blackfire is okay. I'm going to skip this one. I'm going to skip all the slides actually because I want to drink. Everyone here now? So I want just to switch that and go back to the demonstration. So I'm going to remove all the instrumentation because with Blackfire you don't need to change your code. We do the instrumentation. And it's also a big benefit because it means that we can really profile everything. Here you can only profile a portion of the code. So you can't profile what's going on before and after this code. I'm going to explain that. So basically the architecture is you have a C extension like XHProf. It instruments your code. It outputs the data. The data are actually sent to our servers where you can visualize. I'm also going to disable XHProf. Okay. Running again. Fresh. Okay. So as a developer, you are working on in a browser to refresh the page, see what's going on in your IDE probably, and on the client. So we decided to create a browser extension so that you can very easily profile a page from the browser. So we have also a full API, which means that you can you're not required to use the extension, but I think it's a great way to profile a page. So I'm just clicking on profile.
Is this triggering the profile on the back end, or is this just profiling?
It's profiling this page. So this is the same as profiling with XHProf.
Oh, but you have to be on the local machine.
No, actually no. So here, when I click here and I click on profile, it's going to profile this page. Right? It can be on my local machine or on any web server where you actually installed the C extension.
So it just sends like some parameters to the server.
Exactly. So basically it adds an HTTP header with a bunch of information so that we can enable the C extension from the outside. Yes, except that it is.
Repeat the question.
Oh, sorry. So it's more or less like how xdebug works. Yeah, but the thing is, so here we can have a security issue. If you are on a production server, I don't want anyone to be able to profile my server. So when I click here on profile, actually, so I'm connected on Blackfire here, and when I'm clicking here, there is a request to the Blackfire server, so that the Blackfire server can actually sign the request, and the signed request is sent as an HTTP header. And the very first thing that the C extension does is that it checks the signature, and if the signature is not authorized for the server, we are not going to instrument the code. Which means that if you do not ask for a profile, there is no override. So you can deploy that on your production server, no override whatsoever. The override is only there if you are actually asking for a profile. So when clicking here, as you can see, there is a progress bar. So it takes some time. It takes some time because we are actually taking several profiles for this page. So a profile on Blackfire is an aggregation of several profiles. So we can have a stable version of the profile. So that the critical path is almost always the same.
How many does it take?
It depends. The number, so we have the C extension, and we also have an agent. So the agent is responsible for sending the profiles back to our servers. And actually, let's switch back a minute to the presentation. So this is basically how it works. So I have the client, so here this is the browser extension. So the very first thing is I want to send a request. We send a request to PHP extension. We check the signature. If it's okay, we instrument the code. We get the response back. We send a profile to the agent. The agent is responsible for sending the aggregated profile back to the server, but it's also the agent is responsible to determine if he needs another profile, so if it's stable enough or not. So it says, yes, I want another one. We go back to the browser, and we are doing that n times. And whenever the agent thinks that it has something stable enough, it aggregates everything into one profile and sends everything back to our servers. So it can be 5, 10, 20, whatever.
So if it does a small number and then it sees that those are similar, very similar, then it's done.
It stops. If they are not similar,
What does it do if the request you're making makes changes on the back end?
that's a good one. So basically here, if you know that your request have some kind of side effects. So if it is a post request, for instance, you can ask so you can disable aggregation. That's very useful if you want to profile not this page but the very next request. So for instance, if you want to profile a login page, for instance, so you want to profile the response. When clicking on a button, for instance, you can say, okay, I want to actually profile the next request. Okay, when it's done, you can click on this link, and you are redirected to the Blackfire IO server. And here, this is the visualization of my profile. Okay. So here I have the basic information about the page, the time, the I/O, the memory. You have the call graph. So this one is interactive. And as you can see, it's small. It's small because we are actually cleaning the trace before displaying it. So obviously there are a bunch of calls that are not significant enough, so you won't be able to optimize them. So we actually aggregate all those small nodes into one big node. So if I have a look here in the table, I should be able to find, this one, for instance, this node. So its name add something, so this node means that this is an aggregated node. So basically, it contains all the functions calls coming from the standard library of PHP. So as you can see, it's 20,000 calls, small ones. You can't do anything about them, so there is no point in displaying them on the graph. But of course, if one of them is significant enough, then it's not aggregated. So you can see here just below, str/tr is actually part of the standard library of PHP, but it's there because there are a large number of calls, so you might be able to optimize this one. It is significant enough. I'm not sure if I have some other ones, so this is an aggregation for everything coming from the date library, SPL, reflection, stuff like that. Okay, and then for each node you can, yes.
What is the criteria for aggregating?
If it's too small,
You need each of the call is too small or the aggregation?
No. We are aggregating all small nodes, so small function calls that you won't be able to optimize anyway.
Define small.
Sorry?
Define small.
Small depends on the page. So basically, this is something that is less than 1% of the total time it takes for the page to.
So you're basing
generate.
small on time. So if it's taking 1 or 2 CPU cycles.
Oh, no. Oh, okay. So that's because here the focus is on time. But now I can also say I want to focus on the I/O. And then I'm going to have the same kind of graph, but the critical path is now based on the I/O. So this is the same view, but a different dimension. Okay, and then you can click on any node to get more information about the node. So this is the time, the I/O, the memory. This is the inclusive time, and then you can see the colors. So this one was called by one method, and it takes 100% of all the resources. As you can see, the numbers are the same. And this method called one method. So this one is not that interesting. Let's try to find another one. No. Yeah. So here you can see that I have 2 colors, and you can get all the information that you need to actually figure out what's going on. And here you can see that the method itself consumes 2% of or 3% of the resources. So it's mainly about this. So of course, when we are talking about performance, most of the time it's very easy to spot the problems. You have too many requests on the database or stuff like that. So we are trying to be smart in the sense that we are trying to figure out things for you. So we analyze the graph to be able to give you some metrics. So here, Blackfire knows that this is a Symfony app based on nodes, right? So and we are using Doctrine. So we have a bunch of metrics here. So the number of entities, Doctrine entities created for this page. Because of course, if you have too many of them, it takes a lot of memory, which means that there is a big impact for the performance. If it's green, it means that it's okay. Orange, not so much. And red means that you have a problem. And here I have a problem because I'm checking for fresh configuration files. That's bad because we are going to check the time of many files. Here it's okay because this is a development environment, so it makes sense. But you should not have these problems in the production environment. If you have those problems, you need to actually fix them, and you're going to get more performance very easily.
So what kind of what different frameworks is supporting?
So those things are very simple XML files. So there is we have things for Redis, NumPHP, PostgreSQL, MySQL, Zen Framework, Symfony, Twig, a bunch of them. And if you want to add more, it's very easy.
For the user, you can
Yeah, you can create your own methods, and you can share them. That's even better. So okay, one big difference also with XHProf is the fact that as this is a hosted service, we are actually providing storage, permanent storage for your profile, so that you can get back in a month or 2 months and have a look at the profile after some code changes. Right? Because one of the goals of trying to optimize the performance of your code is you make some changes and then you need to check that it actually makes your code faster or not. Right? So one thing that is really important is to be able to compare 2 different traces. So here I have done something very simple. I have the Symfony.com home page in the development environment and the same page in the production environment. And I want to compare those 2 profiles to understand the overhead of the Symfony development environment. So as you can see, the UI is almost the same. Here I have the numbers for the time, the I/O again, and the memory. So the production environment for this page is faster by 100 milliseconds. The I/O is almost the same, and the memory is huge in the development environment, more than 2 megabytes. The data is 2 megabytes in the development environment. As you can see, it's not exactly the same, but we still have a graph here. So blue means better, red means worse. And then those nodes are shared nodes by the 2 profiles. When you have a split like this, it means that the paths are actually different. As you can see here, this is the development router, the development from the controller, and this is the production ones. So that way you can really understand the differences between your code before your changes and after the changes. And even visually, even if it's small, you can very easily spot the problems or the differences. There's a difference here, 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 and here.
What like big changes in the code? Would you like say like you could like act like this was from this commit, this commit? Does that make sense? Possible to say that?
Tag profile?
Yeah, so like profile, make some changes, make a new commit, you want to see different profiles now.
Yeah, so each profile has a name, so you can change the name of the profile so that you can figure out what kind of profile you are working on. So for instance here, let's take a very simple example. So for instance, in the development environment, we are wrapping the event dispatcher so that we can give you information about the events that were dispatched in the WebDebug toolbar. So we have a wrapper, and as you can see, we have the wrapper in the development environment, but not in the production environment. And we are wrapping each listener with an anonymous function. Oh, by the way, here you have the lines where the anonymous function is actually declared. That's not the case with XHProf, which is, very annoying. So the same goes for Twig. We are wrapping Twig so that we can tell you how much time it took for Twig to render your templates, etc., etc. Okay. So we're going to improve this UI bit because now, so this node is faster by 105 milliseconds, which means that this node and all the children are faster by this amount of time. And this node is the same, which means that if you want to understand the gain between those two nodes, you need to subtract 91 from 152. So the gain here is 14 milliseconds. So in the next version, we're going to do the subtraction for you, which is not as easy as it seems, actually. And again, you can do the same for the I/O or the memory. So we are always working on the three different dimensions. Any questions? Okay. You want to drink? So basically, we have a PHP extension agent, so you can install the PHP extension and the agent on your app servers. If you are using virtual machines, you can also say, okay, I just want to install the PHP extension on my virtual machines and one agent per server. That's also a possibility. Oh, by the way, it doesn't work on Windows. Sorry. We have Homebrew, how it's called, Homebrew repository or whatever, so you can just say brew tap, sensolab, Blackfire or something, and then brew install the agent and the PHP extension. And we have repositories for Debian, Red Hat, CentOS, Fedora, everything really.
Do you have plans for Windows? Or
for Windows?
Yeah.
So it's a big problem. So first we're going to have, so we need ZTS support first. So that's something we're going to have next week probably. And then the way you can get information about the CPU is totally different. So basically the extension is going to be very different for Windows. So talking about support, we have a PHP extension. We are working on XHPM1. So anyone using XHPM here? Nobody? Really? Okay.
Question, real quick. Does this work just as well for backend only? Like if you have PHP-based APIs?
Yeah.
Because I saw a lot of UI stuff to trigger recording.
Yes.
I saw a lot of like the UI stuff to trigger the recording to start.
Yeah. So this is one way of doing things. So we have a full API. You can also instrument the code directly. It's very useful for command line tools, for instance. So if you have cron jobs or daemons in PHP, you can do that as well. Sure. So the command line tools are not available yet. We are polishing that a bit before pushing that to production, but I think again it's going to be available in the next 2 weeks. I think that's all for today. If you want to try it out, you can go to blackfire.io, create an account, sign up for a private beta, and if you are doing that tonight, you don't have your laptop. But anyway, if you are signing up tonight or tomorrow, send me an email and I will enable your account right away. Because the waiting list is very, very, very long. And even if we are onboarding 100 new developers per day, it's going to take a lot of time for you to be able to use the tool. So send me an email, Fabien@symfony.com, and I will enable your account. Yeah, any questions?
The only thing you have to install is the C extension.
And the agent.
The agent where, well, I saw that one slide with the said C extension, agent server. So we run the agent server ourselves. That's not okay.
So the agent is written in Go, which means that it doesn't have any dependencies except libc. That's all. It's a small daemon. It does not use that much resources anyway. And we are working out with many different hosting companies so that they can give you the agent and PHP extension pre-configured so that you don't have to do anything. So we are actually working on a build pack for PHP. Hopefully it's going to be available by default for Heroku, but that's not done yet.
So,
it's very easy to install.
Like say you've got a really simple setup where you've got one server in production, you would put the agent and the PHP extension on that server?
Yeah, sure.
Okay.
Sure. Yeah.
How much data are we talking about? How much data? What's the size of the data which is sent to the server? And how is it done? Is it real time?
It's real time. Yeah. The amount of data transferred per profile depends on the page, but I have no idea.
In comparison to the previous UProfiling that you were showing, UProfiles roughly about the same size.
Sorry? Between UProfiler and no, because we are cleaning the profile before sending it to our server. So the profiles are actually smaller than the ones coming from XHProf. Yeah.
I saw something.
Sorry?
Just performance data.
Oh yeah, sure. So it's about the function calls, the memory, the times, that's all. So you don't have your passwords, you don't have your code or whatever.
Is the only agent open source? Is the agent we run Go like open source?
No. It's free? It's not open source.
There was something a few slides back about support for other languages. Is there an API for the agent so we can instrument?
Okay. So for the first version, we are only supporting PHP, but internally we have managed to make it work for Node.js, Python, Ruby, C, C++, Go. That's all. So it works great with Django, for instance, in Python, Express with Node.js. We tested Ruby on Rails as well. So basically, if you are able to give us a code grind file, we can import it into the tool. We are only supporting PHP for now because we want to be able to clean your profile the same way we are doing with PHP. We want to be able to give you some metrics as well. So that's why it's not. So we are focused on PHP first.
At the beginning, you brought up the spectrum of continuous integration, continuous testing. Have you done anything concrete on that front?
This one?
Yes.
So I haven't talked about continuously checking the profiling information. So the first version is really trying to create a better alternative for XHProf or xdebug. So we are trying to focus on the features that you have with XHProf and xdebug. But what we are going to have is automation. So basically, it's going to work a bit differently from neural, for instance. So as we are able to enable the profiling from the outside, so we don't need end users to actually come visit your website to get some profiles. So you will be able to configure some URLs so that we can hit them on a regular basis. And I think it's very important to be able to say, okay, I want to hit this URL and get a profile every day at 2 o'clock. Because you have the same traffic or the same things happening on your servers, and so that you can compare things that are actually comparable. Or at 8 because you have a lot of traffic, or in the afternoon because you have no traffic or whatever. And then you can compare the same page when there is no traffic and when there is some traffic, and see if there are some differences, mainly the I/O probably, stuff like that.
Ford is doing the same, similar thing to this. Ford Motor Company is doing something similar to that.
Which one?
Ford
Okay.
Motor Company. One of the things, specifically working in their security controls area, they were checking to make sure that the customers were constantly on hitting specific pages.
I was going to ask how your how this plays with relatively put all together in the same.
Yeah, try hopefully.
Okay.
So actually on the symphony.com server, I have New Orleans and Blackfire.
Okay.
That works. But that's a very good question. But actually, as we are not doing anything, if you are not asking for a profile, for regular users, it should not be a problem. But that's a very good question. So obviously, we are not trying to replace Neuralink. We are trying to be a good complement to Neuralink. So if Neuralink is saying that there is a page that is too slow, then you can take a profile, trying to understand what's going on. Okay?
So the requests that come from your server, it's all URL based, right? It's a URL getting hit with the HTTP header customized.
From the client to our servers to send a request?
The request that your server makes to our server.
Yeah. This is a regular HTTP request with a special HTTP header so that we actually
So as far as like
activate.
if there's load balancing involved, you don't know necessarily which server will be hit with the extension.
Sure.
But
Sure.
okay, so it can.
Sure. So we also have a recipe somewhere to explain how to bypass varnish, for instance, if you have varnish in front of your PHP app server, because obviously if you hit the varnish cache, you're not going to have any information. So. Yeah. Zero knowledge. Yeah.
Last time you were here, we were talking about something that was similar to PHP PM.
Yeah.
Have you had any updates on that stuff?
So the question is about what I've talked about last year. It was not last year, it was in May this year, actually. So it was 4 months ago or something, yeah. So it's more difficult than I thought it would be. So it's taking more time than I expected, actually. So still working on it.
Is there any plan to make up this
Not yet.
One issue that I always had with so we have a multi-tier system where we have requests on the site, and that makes separation request to and try to trace all the.
Yeah.
Do you have any plans around that?
Not yet, but I'm aware of this problem, but one step at a time.
Right.
Can the running app tell if it's being posted?
Hmm?
Can the running app tell if it's being
Yeah. Yeah.
I guess we just look at the header.
Yeah, exactly. But I would want to be able to provide something that is more fluid.
pass along the same header maybe to another
Yeah,
request on the back end, and you
so
get
it really depends on the agent and the configuration. So basically, we are playing on keys, so public and private keys, so pair of keys really, on the agent and on the client side, and they are, so you need to see the right authorization between the keys. So right now it's not possible because you can't create your own keys, but as soon as you will be able to do that, it's going to be much easier.
But can you replay a key?
Sorry?
Can you replay a key that you get once?
No, you can't. No, you can't.
If you have a multi-node environment, do all the servers that you have your extension on have the same key?
They can have the same key. They can. They can. The signature are not going to be the same because the signature depends on the time. So the signature is only valid for 10 seconds. Afterwards, you can't use it anymore. Okay, thank you very much.